Hello, welcome to this How Do I video in which I'll show how to use the Management Portal Web Service API to create a demo experience for your prospects to enable them to self-provision demo instances of your offering powered by Microsoft Dynamics NAV. In this video, you'll see a demo ASP.NET Model View Controller application that talks to the Management Portal API and enables your prospects to self-provision a demo experience of your solution. I'll do this in 4 steps. First, I'll create an ASP.NET MVC application and create necessary models, views, and controllers to process self-provisioning of tenants. Then, I'll create web references to the Management Portal Web Services, as well as a small utility framework that simplifies instantiation and authentication of these web services. Then, I'll implement the business logic of the provisioning, and finally, I'll test the application to see if it works. Let's get started. Management Portal is intended for partners. In a truly repeatable world, you'll want to have a website that your prospects find using a search engine and sign up for your solution without you having to even know about them, just like Office 365, Azure, and many other cloud-based solutions. Obviously, we need a web application. Using Visual Studio, I'll create a new C# Web ASP.NET project and choose MVC template. An MVC application consists of 3 mandatory layers: models that represent data that your application uses, views that represent user interface that will be presented to users, and controllers that act as an interface between users and data, process the application flow, and invoke business logic execution. Let's create all of these. First, models. I'll start with 3 models, one to represent the tenant, one to represent the tenant user, and one to represent the application configuration I'll want to provision. My tenant model contains the fields I'll present to the user, such as company name, tenant name, and country, but also a few fields that I'll use internally, such as ID and URL. As you can see, I can decorate my model properties with attributes to specify whether fields are required or to specify more complex data validation. I can even include remote validation, such as tenant name availability validation, to indicate to my users whether a tenant name they want is available. The next model is my user model, again with necessary information for both my users and my business logic. Finally, the features model is intended to keep tenant configuration. This is just an example, and this model could include much more information needed to configure your vertical solution. I'll create one more model, and I'll call it provisioning model. I'll use it to contain all 3 other models, but also, since the provisioning will be achieved through a wizard, I'll use this model to keep track of the current page in the wizard. Now that the models are here, let's create the views. First, my index view will simply contain the information to show on my landing page. Here I'll have a link to my sign up page. When users click it, it invokes the index action of the sign up controller. Sign up itself will be handled through 3 views. First is index, and it manages the wizard. It renders partial view for the steps, as I will define them in the controller. The next view is status view. It will show the provisioning status to users while the provisioning is in progress. Finally, we have the completed view, which shows the completed sign-in information, including URL, username, and password. My wizard will comprise several steps. Each of these steps is represented by a partial view. Each of those simply maps form fields to model properties, and the MVC framework will take care of all the rest. Finally, my controllers. The home controller is there by default, and I'll need to create my sign-up controller myself. Controllers simply group actions, and actions are invoked either by user or code. My sign-up controller has the index action, which is in charge of the wizard. At the beginning, it will initialize the wizard, which is simply an array of named steps, and state, which is an instance of a simple class that allows me to store objects and flags in a thread-safe way. My index action checks whether I am navigating past the last page of the wizard, in which case it redirects to the create tenant action. Otherwise, it simply instantiates a view, populates it with the known information, and then the MVC framework renders the index page with the correct partial view. For now, I'll leave the create tenant action alone. I'll fill it in with code to invoke provisioning business logic later. For now, I'll simply redirect to the status action. The status action constructs the view from the current state and returns it to the MVC framework for rendering. Last action I need here is the getStatus action. This is the action invoked every 2.5 seconds by the status view that will retrieve the current status from the current provisioning flow and return it as JSON back to the status view for rendering. I'll also complete this action later. So, we now have a skeleton and we are ready to add some smart stuff to it. Let's first create web references to the management portal. This topic is explained in the How Do I video on getting started with Management Portal Web Services API, so I won't go into too many details here. I'll simply show the services I connected to. I'll need the application tenant service to provision new tenants. The application tenant company service is here to allow me to rename companies. Application tenant user allows me to provision new user accounts from the tenant. Operation service is important because it allows me to inspect the current tenant provisioning status. And then I have 3 more services that are tenant services and not the management portal services. I'll have the company information service, then GL setup service, and finally the tenant user web service to manage user permissions. For now, I only have 7 services, but there may be many more in the future. To avoid code duplication, I'll have a few helper classes. First, I'll have one static class to keep service names. Each service that my application ever becomes aware of also becomes a property in this class. It has a subclass called tenant to group tenant services together and separate them from management portal services. Then I have one static class to keep track of my management portal configuration. Here I put my base URL, username and password, application service name, default company name, and I have one helper function that returns a service name from the configuration class into a full URL for the SOAP web service specific to my partner tenant. And I have one last static class here that I called Web Service Factory. Since all web services inherit from the SOAP HTTP Client Protocol class, I can handle instantiation of specific service types, assignment of URLs, and credentials in one single place. Here, I have one generic method that instantiates any SOAP HTTP Client Protocol descendant, assigns the requested URL to it, and secures it using credentials based on my configuration. Then I have a number of named static methods, each representing a service to handle. Each of these methods invokes the new service generic method and returns the specific service instance ready to call into my management portal partner tenant. These functions are slightly different for the customer tenant services, but the principle is the same. Great! Now that I have my web services and infrastructure to invoke them, let me go to the next step and write business logic for provisioning. Let's start by decomposing the provisioning process into a series of steps. At a very high level, I need to do 3 things: provision the tenant, provision the administrative user account, and set up the company. However, each of those steps contains a number of sub-steps, resulting in a hierarchy of individual tasks that have to be completed before my tenant is ready for my prospect customer. I want to tackle 2 issues here. First, not all of these tasks need to be executed in sequence. Some of them can certainly be executed in parallel. The next issue I need to tackle is that the user's web page must not be unresponsive. In fact, it must show the feedback about the provisioning as it is happening. This means that I'll have to have some way of executing the provisioning asynchronously. For that, I have created a small workflow framework that handles execution of tasks in a generic way, by allowing me to create basic tasks, asynchronous tasks, or to group tasks into groups that execute as one task. This framework allows simple binding of predecessors and successors together, as well as make tasks preconditions of other tasks. Each of my high-level provisioning tasks becomes one provisioner class that inherits from a workflow base class. It simply overrides the request tasks method that the workflow uses to request tasks before executing them. Let's inspect my tenant provisioner class to see how it operates. You can see that it's a hierarchy of async workflow tasks, each of which establishes predecessor-successor relationship by invoking the then method. In my first task, I'll create a new tenant. I first subscribe to the createCompleted event and then invoke the create method asynchronously. To it, I pass the tenant information from my view that my extension method converts to an instance of an application tenant class the web service understands. Inside the createCompleted lambda delegate, I invoke the framework method that checks whether asynchronous operation succeeded or failed, and then completes the current task. When the current task completes, it automatically signals to the succeeding tasks that they can begin execution. Here I have only one succeeding task, that invokes the begin provisioning method. Again, it does it asynchronously. And then from the completed Lambda delegate, it checks the results for success or failure and signals to the next task to begin. This principle is applied across all my provisioners. There are asynchronous tasks, and each invoke one individual provisioning operation asynchronously and signal to the next task to begin once they are completed. Many of them store the information received from the service in the state object, and some of them explicitly wait for some other tasks to complete, or set flags signaling to other tasks they can proceed. There is one more level of workflow hierarchy, and that is again a workflow task group instance. This one simply invokes the tenant provisioner, and when it completes, it simultaneously invokes the company and user provisioners. A couple of more things. Let's go back to the sign-up controller. Here I'll complete my create tenant action. It will simply instantiate the provisioning manager class, run it asynchronously, and in its completed action delegate, set the state of the whole workflow to completed. Then it redirects to status action. Now while the website is showing to the user, the provisioning is diligently doing its work in the background. Finally, my get status action, the one that's invoked by the status view every 2.5 seconds. It creates an instance of an anonymous type, adds the steps from the workflow, current status of the workflow, and current error messages, and then returns this object as JSON to the status view. One last step is the validation controller. It will be invoked automatically by the MVC framework for the tenant name property of my tenant model, and it will check whether a tenant name is available. My sign-up view will use it to visually indicate to users whether the tenant they want is available or taken. Okay, now that everything is done, let's test it. Here, I'll click Sign Up, then accept the terms of service. Then I'll specify my company information. As you can see, if I choose a name that's already taken, the tenant name field immediately indicates that. I have to choose a tenant name which is available so that I can proceed. On the next page, I specify my administrative user account details. On the next page, I configure some of the application features. These are just demo features. In your actual real-life provisioning applications, you'll put those that make the most sense for your prospects. The next page shows the summary information for my tenant. If everything is okay, I can click Next and begin the provisioning process. Here I can see the actual status of individual tasks. As a task completes, it indicates that it has completed. Once the provisioning completes, I'm redirected to the welcome page. Here I will copy my temporary password and click the web client URL. I'll sign in, change my temporary password into one that I want to use regularly, and I'm inside my demo tenant. You can see that the company has been renamed. Also, the company information card shows that company information has been configured as specified, and the same is true of the general ledger setup card. Let's wrap up. In this video, you have seen how to create an ASP.NET Model View Controller application and on what principle MVC applications operate. Then you have seen how to create a simple set of tasks that simplify access to web services by maximizing code reuse. Then you have seen how you can asynchronously call management portal web services and customer tenant web services to provision and set up a company. And finally, you have seen how a typical provisioning application to help your prospects create their own demo experience of your solution may look like. In this video, we have covered the ASP.NET MVC concepts, Management Portal Web Service API for managing tenants, and asynchronous invocation of web services. To learn more about the Microsoft Dynamics Managed Service for Partners, please visit http://aka.ms/NAV Managed Service. Last but not least, the ASP.NET solution that I demonstrated here is available on GitHub. It is provided as is, it's an unsupported community project, and it comes with no warranties. I hope it provides a good kickstart for you to start developing your own provisioning websites. I hope you enjoyed this How Do I video. Thanks for watching. Keep calm and provision on.